All right, guys, I want to welcome you back to another KevCAM night class tonight. Tonight, I have Mr. Welsh helping out with any questions, concerns that come up along the way. Steve, are you with us?
Yeah, as long as they're not super technical, Kevin, I'll be able to help in any way I can. So.
No, that sounds good. I see we got.
Yeah, appreciate.
Oh, good.
Well, yeah, just quick. Was gonna thank everybody for the time this evening, Kevin, and looking forward to a good session. So.
Yeah, absolutely. So for those of you guys that are new, that are kind of seeing a couple people dripping in here, we do use GoToWebinar to host these. And, you know, if you guys do have questions, definitely put those in the questions panel. Everybody is on mute just to eliminate any background noise, and we'll get the ball rolling. For those of you guys that are new, let me throw this slide over. If you guys send us your ideas, we'll send you off some SolidCAM swag as a thank you. You guys can send those ideas over to me via email, and I'll put my email address into the chat for you. And then, as always, we do record all the night classes, and started this YouTube channel about 1.5 years ago. And let me get to it here. If you guys type in KevCAM or go to SolidCAM University, should pop up for you. And for those of you guys would like the quick link to that one, let me put that in there for you guys. And there's the link in there. Yep.
You're up to about, what, 120, 130 videos on your site these days, I believe.
Yeah.
Maybe more.
Yeah, I don't even know how many videos I have. I don't know if you go home, it will tell me. Yeah, it doesn't, there's a lot in there. So if you guys are looking for something, definitely come there, check it out. If something's not there, let me know and we'll add it in there for you. I know last week we were talking with the port machining on some of the advanced features in there, and Mark is actually going to do a quick little video on kind of covering what that advanced page kind of goes over in more detail for you guys. That's kind of going to be the kind of the same thing for tonight. We're going to kind of go over the basics of the multi-blade. We're not going to get anything too deep on more advanced. We are going to be doing impeller machining tonight, or multi-blade machining tonight. I do have a part that is programmed up for you guys. Some of these larger files do take just a little bit of time to save and calculate, especially I'm running a pretty old machine here for the night class computer here, but and I want you guys to sit and wait through that. So all of you guys do have this part in your arsenal. If you guys go to, let's pull it up right here and go to your C, user, public documents, SolidCAM, and whatever version you're running, SolidCAM 17, 16, 15, 14, whatever. And under the user, getting started examples for SolidWorks, that part is in there. So right here this is the part that we're going to be kind of covering tonight. So if you guys need a good reference spot, you can definitely come there and check that out too. But I guess with that being said, we'll get the ball rolling here. Multi-blade is specifically just kind of meant for, you know, pretty much impellers and impellers only. That's why this module is an additional module that you guys can purchase. That if you guys are doing a lot of impellers, this is kind of where, you know, this is definitely going to make your life a lot easier. Not saying that you can't do it with 5-axis machining. It just takes a lot more finessing with 5-axis machining, and they really simplified the multi-blade and how it works. So for the first one right here, we'll be covering roughing. So if you grab the drop down right up here, we have roughing, blade finishing, hub finishing, and the fillet finishing. Roughing is just kind of doing what it's saying, you know, roughing out the area. Blade is to finish off the impeller blade, and the hub finishing is to finish off the hub and the fillets. So pretty self-explanatory right there. For the geometry now, we have a couple different strategies we can do. We can do morph between hub and shroud. We can do parallel to the shroud or parallel to the hub. And for those of you guys that are curious, the shroud is going to be the outside kind of fins, and the hub is going to be the inside right here. So I'm just going to kind of show you what I did here. Is we're grabbing these blade faces. Yep, go ahead.
I was just going to say, Kevin, yeah, I think you hit the nail on the head. One of my customers was doing a lot of this type of part and had 5-axis simultaneous. He could get the job done in our base 5-axis simultaneous package, but I think he told me somewhere in the neighborhood of 3 hours it cut down on his programming time just with this module because it's specifically designed for these types of parts. So that's kind of the fit for the module.
Yeah, absolutely. So your return on investment is going to be pretty quick.
Can be quick.
Yep. So we got our blade fins there. Our hub is going to be, just our center hub right here. So that's just kind of our center area. And then the shroud is going to be just the outside fin. And I can grab this fin right here or this one over here, really doesn't matter. Just the outer area of it. So it kind of knows where to go around. Now I'm telling it to leave, this one's in metric here, so we're doing 0.35 millimeters on the blades in the hub. So we can come back and do a finishing cuts on those. Now, quite a few different tools you guys can use for this impeller machining. So we can use a standard end mill, a bull nose end mill, a ball end mill, taper end mill, or a taper ball nose end mill. And they're actually getting to add in the barrel cutter also. And then, of course, lollipop cutter right here. So
kind of nice too, Kevin. Same workflow as basic regular SolidCAM.
Yeah, and that's the one thing I really like about, I've used a lot of the other CAM softwares out there. The thing that really makes, I at least personally like is everything is all set up the same. So it doesn't matter if we're doing multi-blade or face milling. It's all kind of set up the same way. Just a couple, few or less added ones in there for you guys. So now levels, we're going to just be doing a severe. And this is all these that I've kind of covered so far, except for geometry. I did the morph between hub and shroud. These are pretty much the default values in here. The default values are coming very good. So there's not a lot of finagling that you guys have to do or tweaking that you guys have to do to get at what you're looking for. So this is just kind of our clearance, our safety zone right here. So just doing a severe. Going around there, got a 2 millimeter safety for the entrance and exit for the safety distance right here. So toolpath parameters. So right here is, you got your cut tolerance like we normally do, but splitter follower smoothing. The tighter I make this and scoot this over, the more it's going to pick up on each individual little point. Where, let's say I'm sorry, I said that wrong. The more I move this over to the right, the more it's going to smooth out and kind of gap out those points. The more I move it to the left is going to pick up on more points. So it's going to be, not saying it's going to be inaccurate, but it's going to leave a smoother finish, I guess, what I'm kind of getting at. And same thing with the tool axis smoothing here. So it's going to keep things smooth, looking nice and smooth, kind of going through there in and out. You guys can definitely play with this, but like I said, a lot of these defaults are, pretty well set for you. In the technology now, here's kind of where you set up your step downs and your step overs. So right now we have it set up by number of steps. So we're doing 10 steps, but if you guys want to do a distance, you guys can turn on the distance right here. And same thing for the slices. Here's your step over, kind of moving over into the material. So we're also doing 10 passes down. So we're taking 10 cuts going down in, and we're taking 10 cuts going over to the left, to the right. And then we can actually sort that out by how do you want to approach it. So we have one way, start from the leading edge, one way from the trailing edge, zigzag starting from the leading edge, and zigzag starting from the trailing edge. Starting and trailing is going to kind of based off of your shroud and your hub. And then we have orientation, the ordering. So if you want to do left to right, right to left, center away doing climb cut, or center away using conventional. So a couple different options right here. Now this screen and this one right in the tool axis control, there's not a whole lot in here, and that's because it's taken out it's it's like hitting the easy button. I guess the good old Staples easy button for the multi-blade. So it takes out a lot of that guesswork for you. The edges, so we can do the rolling over the edges. So this is as it's transitioning the tool path up and over. It's kind of what's going on right here, and then down here at the bottom. So you can actually do, full trimming with a radius by length, arc, all that stuff. Just going to leave it set to automatic. Let it do its thing here. Now you guys can set up. This is the default values when you start a new multi-blade operation right here. Now you got a preferred leading angle, so you can say, I just want to do, a lead angle of 5 degrees. You can do a minimum lead angle of, 0, maximum lead angle of 45. So maybe a 5-degree angle is going to be your preferred sweet spot, I guess you would say. And then you guys can do a side tilt angle too. So kind of like that lead leg angle, like you guys had the option with the full simultaneous 5-axis for you. And same thing here with the limits. So we can set our machine limits. We can set it to, I want to machine anywhere between 0 and 91 degrees. You can set up steps in there too if you want. And this is really kind of splitting hairs now, kind of when we're getting into this side of things. Linking, leave it on automatic because it's gonna give you the best results. Kind of linking in there, connecting all the passes for you. For this one, what I did here is under the sorting, I did the zigzag. Default was one way. I did have some retracts, so I just did a zigzag from the leading edge to kind of eliminate all that for you. Gouge check, same as kind of what we've seen before. Just, you can do a check surfaces. It's automatically going to be looking at that, at the SolidWorks model for you, and, not gouging in, but if you wanted to set up a check surface area, saying not to touch the specific area, that's where you can come set it up right here. Clearance data, kind of just for your tool holder, same as what we've always seen before here. And then here's a little bit different one here. We can pull up, and then we did this on the port machining too. And some of the other 5-axis ones, you guys can set up your stock as automatic, or if you just want to pull from specific operations, you guys can do by selected operations, or you guys can bring in, an STL file. I haven't done the FTC file here. I'm not sure what the .ftc file is, but I can definitely look into that a little bit more. That one's just kind of a new one for me. And then you can put an over thickness on that too. So if you want to thicken it up, let's say your stock is, X size, and you want to just kind of put a offset in there if you wanted to. And now when we're doing our multi-blade, we really, our main focus is just to get that one, the 2 blades done. You got the main blade, and then you got the splitter blade. That's our main focus. That's all we really care about, is just getting that one done. Don't try and kill yourself and do them all at once. Just worry about getting one done, and then we can come in here and do our rotation. Tell it how many times you want to rotate around, and it will populate that to get the entire impeller done for you. So if we take a quick glance at the toolpath, what's going on here. So here's our multiple passes coming in there, and you can see it's not cutting air at all. If we do a side angle here, keeping down in that stock, stepping down what we've told it, going all the way down through there, kind of getting all that material roughed out for you. Nice lead, doing arcs going around and then coming back in the material. Same thing coming in down here, arcing out and then coming back in, keeping that tool nice and smooth going throughout that pass. Hopefully get a good shot for you guys here.
Kevin, and that's a pretty complex impeller, right?
Yeah.
So,
I mean, impellers will always vary, the pitch of it and all that stuff. But this is kind of a good middle of the road impeller from what I've seen from customers, from going to 3D Content Central and going to GrabCAD. So
cool.
Yeah. So let's just take a peek here and see what this looks like. So you see I got my vise in there. Not really, I did have some additional stock on there, but play it through. And it just, I mean, in no time at all for you guys, you're getting a complete roughed out operation right here. Now there is one other way of kind of going about this. What we could do is set up, if you didn't want to use the roughing strategy inside Impeller, what you guys could do is set up a secondary coordinate system, tilt it over so it's at an angle, and we could also use 3D iMachine to rough it out. But it's not going to get as deep and as good in there as what the Impeller roughing strategy is going to do for you guys. So just because it's, I mean, this toolpath is specifically made just for Impellers. So
Kevin, and good results too. I know this is probably a SolidWorks model, but just as good as results on like other import step files, stuff like that.
Yep, absolutely. And this is going to work good on any file. I mean, if you bring in if you get a dumb solid, anything that can open up in SolidWorks will get for you.
Perfect.
I did see one person kind of ask about price. Now,
got it.
Yep, and this is something I haven't mentioned for a while. I kind of forgot about it up until a couple weeks ago. If you guys are interested in any of the stuff that we're showing here in the night class and you don't have it, Steve hates me saying this, but tell your account manager that you want the KevCAM discount, and they'll knock a little chunk off for you.
They will.
For sitting in and watching these night classes.
Absolutely. Yep.
Because like I said, you guys are our main focus, and we're going to do whatever's going to make you guys more productive and, you know, get better results for you guys. So
good. Okay.
So what I'm going to do is I'm going to kind of cover the roughing, get into the finishing stuff, and then what we'll do is we can do a transform and transform these around. You know, if I want to, I can definitely do it right now too. I can switch this. I want 5 segments going around 5 times. Do save and calculate here. And now we have our entire impeller all finished up right here. So completely roughing it all out, getting everything up to the 0.35 millimeters that I specified that I want to rough it out to. Now, if you guys are looking just for, if finish isn't too critical, I mean, impellers are usually pretty critical, but if you do have that option where, you don't need it to be super critical just for maybe test fitting or something like that, definitely, I mean, feel free just to come in here and just use the roughing strategy and, change your geometry over to 0 to stock leave. It's going to be a little bit rougher finish in there, but that way it'll give you kind of a good general idea before you get through and finishing off the entire thing. Okay, so now we are going to do the blade finishing. So we want to finish up our blades. Now, like I said, keep your focus on, we only have to really do the one side of the blade here, our center splitter, and then our other side, our blade right here. So if I do a show here, actually this one I'm just going to work on this blade right here, and then we'll get over to this one. So I've got everything selected. I don't have to select that top face. You'll see that this, if I can get a good view, this portion right here, that does not need to be selected. Just grab your outside perimeter for you. The only reason that you would need to select this is if this wasn't coming off the lathe and you're just kind of working with a square block, then you would need to. But since this was already turned down, you've seen my stock, that there's no need for that at all. Okay, so we got our hub, and I'm not going to bother showing you that. The shroud, same thing as before, just grabbing that outside top face right there. Now we're not leaving any stock on this one. We switched over to a 12 millimeter taper ball end mill. Levels, same, default values right here. Tool path parameters, pretty much the same right here. Now, we have our tool axis smoothing. We don't have our, oh, I'm having a brain fart here. What was that? Splitter following smoothing, just because we don't have a splitter to even worry about. So technology, how do you want to do that impeller blade? So we can do full, we can do trailing edges, we can do leading edges, left side, right side, and more of a pocketing style. For this one, we want to kind of follow that blade, kind of going over and around, kind of going back and forth. Now we're doing, 15 steps going down in there. And like I said, you guys can switch it over by distance. And then definitely set up if you guys want, you guys can tell it to stay at, 5 degrees and work between 100 degrees or 0 and 90, whatever you guys have for preference for you. And then we'll do kind of same thing. Right here, we have, your sorting. How do you kind of want the tool path to kind of run? We got one way, start from the trailing edge, zigzag, and zigzag from the trailing edge here or leading edge. For this one, try to stay with the one way. I mean, I'm not going to tell you how to machine apart at all, but you'll get a nicer finish if you stay with the one way, because then you can climb cut instead of doing a climb cut, then conventional cut, climb cut, conventional cut, kind of going back and forth. So you get a much nicer finish kind of going on right there. Tool axis control, same default values as what we just brought in. So I'm just going to leave my default values in there. Same thing with the linking, leave it on automatic. Don't have to worry about touching any surfaces right there. And our stock is all good, and we don't have any rotations in there. I'll just show the tool path here. And you can see doing a nice contour with that end mill following along the contour of that blade going all the way around. And, we could smooth this out a little bit. Like I said, and if we did a zigzag, we wouldn't have these retracts, but like I said, we're going for, a nice looking finish here. We want to get those in there. But before I said I wasn't going to do this, and I ended up doing it. Let me go to my rotation and put these back at 1, so I don't have to wait for my updated stock to calculate for the next operation here. All right, so let's go ahead and simulate this.
And then, Kevin, at the end of the presentation, you're going to show how you'd program this with just 5-axis simultaneous software, correct?
Yeah. We actually did, for those of you guys that were here when Justin did that impeller, I see a lot of familiar names in here. We have so many people that come in out of these classes. So for those of you guys that remember, he went through quite a bit of work to do that impeller, if you guys remember. No, unfortunately, I'm not programming them live, and I would love to program live with like this part and that port machining part, but that dead silence air just kind of kills me. That's calculation time just waiting for it. So I don't want you guys sitting there falling asleep as we're waiting for this to calculate. And you can see as I calculated this roughing one, it wasn't too bad, but I just want to keep the kind of flowing for you guys so I don't put you to sleep. So now,
I think the port machining, same thing, Kevin, right? Specific to those types of parts, and if you're doing those types of parts, it can save a significant amount of time, no doubt. Yeah,
absolutely. As it was kind of coming around this side, you kind of see, well, we're kind of gouging in there. Well, you got to remember, with that first operation, we would have had that transformed, so all that material would have been, gone already for you. So that is the blade. Now we're going to finish off that splitter now. So basically all I did is just did a save and copy, switched my faces to cover that splitter. Like I said, we don't need that top portion there, but it is selected. Hub is going to be the same, shroud's still going to be the same. For the shroud on this one, I left it on that top one right there just because it's got a longer, with that splitter. We can select this and should get still good tool path, but I just kind of like to be a little bit more cautious, and the more area I can select for that shroud, the better off we're going to be. Same tool, same levels, same tool path parameters, same technology that we're kind of going on here, same sorting. Basically want to achieve that same, basically that same tool path is what we did for the large blade is for the splitter right here. So you can see it's going to look identical, obviously just a little bit shorter here coming through. So it's kind of coming in there and rotating around. And if we just do a simulate here. Working our way around. So we got our main blade and our splitter done. So we're done having to finish off any of the blades anymore. Now we just basically have is the hub left, and the small little radius is kind of going around the bottom of those blades. So now we'll do our fillet, and like I said, just kind of cleaning up that bottom right there. So we can actually grab the same geometry as what we did before using that finishing the blade, because it's just going to be basically looking at the fillet. If you guys just want to select that fillet by itself, absolutely. I'll show you here. If we get digging a little bit deeper here, is we can just tell it how many passes I just want to do on that fillet. So we're using the same cutter, same levels, tool path parameters, kind of the same. Technology is all the same, but I'm telling it to do 8 cuts. So just working on 8 cuts on that bottom. And I can do, by the hub side, a number of cuts. So I'm doing, on the hub portion, I'm doing 5 cuts right here, and on the blade portion coming down, I'm doing 8 cuts. So just focusing really on that small radius in there. Sorting, doing one way to get that better finish. Now, how do you want to approach it? Do you want to go from the bottom up? You want to go to the top down, inside out, outside in? How do you want to approach your, kind of think of it as your morph between boundary curves? How do you want to approach that? So for this one, we're going to start on the bottom and work our way up. So basically hub up to the splitter here, or the blade. Sorting, all left on automatic here. Tool axis control, all default values again. Linking, all that's going to be the same. Let's just see our tool path. So you can see we got, I'm going to try to get focused in here. So we should have 8 passes going up. I'll just count real quick. 1, 2, 3, 4, 5, 6, 7. Yep, 7 up, and then 5 going over to the side. So really just main focusing on that bottom fillet going all the way around for that smooth finish in there. Let's go ahead and do a simulate here. And once again, we are hitting material over here, but you got to remember that material will be gone just because of the transform that we didn't do. So we got that fillet all nice and cleaned up in there. I don't have my facet tolerance set real tight, just so we could get through the simulation much faster for you guys. So it's going to look worse than it actually is in here for you, but I got a pretty loose tolerance in here. But you can see, I can get a kind of zoomed in shot. I don't get a very good angle here, but it's got a nice smooth path kind of going all the way through, following that bottom radius. And if I just pull it up here, you kind of get a good view of it going up and over. Like I said, you guys can definitely switch this over to zigzag to kind of eliminate this jumping around right here. Just remember, you probably won't get quite as nice of a finish if we're doing a zigzag versus the one way. So now we just got the, so we did the fillet on the big blade. So now we just have the fillet on the splitter. So basically what I did is just did a save and copy, switched my geometry around to the faces on that splitter. And since I already had everything selected, I didn't even have to go through and reselect everything. I just grabbed that same geometry as I was using before. One thing that kind of came up, and I apologize, I like to get off on these tangents, but it's completely non-related, but somewhat related, is if you guys, I'll open up this operation. If I'm trying to edit this faces one, get this error saying geometry is used in another operation. It's basically telling us that we're using that geometry in another operation. You need to modify it from outside there. So to kind of get around that, what you guys can do is, if you just hit the expand button out right here, you can actually right click and do an edit on that face right there. And then you can actually do any edits that you need to in there. That will update all the geometry that's using that faces one. So for any of your geometry, even some of these on like 2.5D and 3D, the levels will show up and stuff like that. You guys can come in here and grab those and just modify it from there instead of actually having to open up an operation itself. So, okay, so we got that faces 4 selected. Same tool, levels still the same right here. Toolpath parameters, all same. Pretty much just did, like I said, a save and copy and switch that faces over. Show up our toolpaths right here. Coming in there, leaving our same steps, doing 8 steps up and 5 steps over. Can I get a decent view here for you? So you can see coming down 8 steps and then kind of coming over is 5 steps to get a nice blend for that small radius going around that splitter blade. All right. Now the last. This is kind of the fun part more than anything. Finishing up the hub. So for finishing up the hub, I'm going to grab my 3 blades that I've been kind of focusing on right here, kind of going around. And I'm just going to rotate around so you guys kind of see what I got all 3 of those selected. What is my hub? So I just selected my hub area right here. Using that same tool, skip over levels. Now we have our splitter following smoothing and our tool axis smoothing again right here. Technology, how many slices do you want to take? Basically kind of your step over, if you think it is that. We can do by max distance too, but what's your maximum step over, or how many steps do you want to add in there is what we're kind of shooting for here. Sorting, how do you want to approach it? This way I'm going to do a zigzag to eliminate a lot of the retracts going over. And, you know, since we're working, you know, more on the tip versus the side of the end mill, we should get a decent finish going in there, working from the left to the right. Edges all set to automatic. Tool axis control, these are all, like I said, default still numbers right here. Linking, all default for you. Nothing to gouge check against. And, you know, I could do a check surfaces against the blades because I don't want it to touch there. But what I actually did here is in the geometry, I forgot to go over this, is I did a stock to leave. So it's leaving 0.15 millimeters away from that blade surface and that radius. So we're not touching into that at all. All right, we're at gouge check. And clearance area, that's going to be just the holder. And then your stock definition, we'll just leave it at automatic. And let's show the toolpath here. And just coming in there and doing that finishing pass, working on that area. So if we go ahead and you can kind of see, kind of coming in there and just focusing on that hub only, staying away from the wall of the blade, staying away from the splitter here. Let's do a simulate. And unfortunately, I didn't do a solid verify on those other ones, so it's going to update those stock for us. There we go. So you can see where we worked, smoothing out that radius right there, and now we just need to finish off. Now the finer, so like right now we did 18 steps. Now we can definitely take that and go to the extreme and do, like a 2,000 step over, and that thing's going to look like a mirror in there. So it all depends on what you guys are looking for tool finish. But keep in mind, as you increase, those step overs or increase the number of passes in there, your cycle time will increase also. So I guess I went through that kind of fast.
Well, Kevin, one thing I was going to say, it looks like there's a lot of automatic parameters set in there default.
Yep.
But we still give the user control at the end of the day to fiddle around with any of those parameters that they'd like to. Correct?
Yeah, absolutely. And that's kind of the same thing through all of our operations in SolidCAM, especially this one, this one and port machining. A lot of automatic stuff is set up for you guys, but you guys still have full control. You're never, machinists, we want to control as much as possible, and when the automatic is not doing the trick, we want to be able to fine tune it to our liking. So you guys have the ability to go in there and play around, maybe, that preferred angle is, instead of being 5 degrees, is, 25 degrees. So definitely come in here, and you're not locked out of anything. Same thing with the rolling edges. You guys have the sky's the limit on what you guys can do for those rolling edges going in kind of exiting and entering around those blades. So definitely a lot of stuff in here. To make things a little bit easier too, as you guys are kind of getting started with this, is turn off the advanced tab. That's going to simplify a lot of things. I always kind of forget about that. I know we kind of went through the HSM and HSS. They all have that advanced. I always have that on just I'm so used to it because I need to see and know what's going on. But kind of to simplify things a little bit for you guys, turn off that advanced, kind of get the ball rolling, and then that's going to eliminate a lot of the stuff that really don't need in there. But if you do need it, it's right there for us. So. Yeah, and I mean, we have it select to auto detect the dimension and positioning. But if you guys, want a little bit larger, uncheck it and crank up that radius a little bit in that sphere height, and it will automatically add that in there for a clearance for you. So you're not locked out of anything at any one point in time. That's another great benefit, I think, over ours versus, CAM software is a lot of those other ones. It's you do it this way only. If it doesn't work that way, well, sorry. That's not the option here. So any questions, guys? So do they have any plans for 5-axis? Yes, they're actually more working on plans for more of the 3D iMachining finishing right now, but that is the plan. And with iMachining and the algorithm that's built in, it is quite the complex animal, just because it's all based off a chip load, an axial contact point of the tool, and when you start getting into ball end mills, that completely changes the scheme of things. So they are in the process of getting that. My assumption is once they kind of get that set for 3D, it should kind of carry over into the 5-axis side of things for you. So let's see, are we doing the time just for roughing one set or all the way around? Well, I guess, Ben, I'm not sure on your question there. Let's see. Just for one round. So what I did, Ben, is I just did a main focus on just getting this area kind of cleared out. So now that I have that area kind of cleaned out, like we'll take this roughing strategy. Now I have my tool path looking good. Everything is looking good on the simulation. Clearances are all good. Now I can come in here and go to my transformation, go to rotation, tell it, I have 5 blades, save and calculate. And now I got my toolpath going all the way around. And that's the same case for all of these. So if I come in to finish off this, the blade face right here, go to my transform, rotation, switch this over to 5, save and calculate. So now I'm just kind of going through and just turning on so it goes all the way around. Let's see, will our time estimate include roughing and finishing the part as you have? The cycle time, are you looking at? Yes.
Yep.
So once you have done that, that transform, you got the, everything good, your cycle time will be dead nuts on.
For the full part.
Yeah, for the full part. I kind of say, there is a little bit of buffer there. At the machine shop I worked at, we had ours dialed in pretty fine-tuned within, 5 to 10 seconds accuracy. And it all depends on, the post. And if we get into the nitty-gritty of, what's going on, you guys have the options for slower tool changes in the working style. Now they've always changed up this post on me, so it's been a little while since I've been in here, but you guys can actually modify the parameters of, maybe your machine excels and decels a little bit faster. We can implement that time in here too. So if you guys are curious to get that time a little bit more accurate, or if it's way off on something, let Eric know, and he can get those timing values changed over for you. So,
yep.
But great questions, guys. So
like
I said, as you're going through this, just focus on that one blade, or the blade in the splitter, get that done. And then, once everything looks good, happy kind of with that, then as the last thing to do is come up and do your rotations right here. So, and if you want, Ben, what I can do here is, since we have all 5, or these first 3 operations, if we just do a simulate, and we can just do a host CAD right here. Now I haven't set any feed rates for those tools, so you can see our time is right here. So 15 hours, 1 minute and 17 seconds is the total time, but those feeds are probably my default feeds, and I didn't set any of those. So, any other questions, guys?
Quiet group tonight, Kevin.
Yeah. How many people are gonna go out and buy Multiblade now?
I was just going to toss that out there, that if there is anybody interested, we'd love to get it in your hands for an eval period too. So
yeah,
contact your local representative or SolidCAM.com. We'll be happy to get back to you and put it in your hands to kind of kick the tires, as they say.
Oh, and Ronnie has a great point here. You can actually show the cycle time in the operation. So if we go to, where the heck was that again? Operation here, cam tree view, and we can show machine times. So you can kind of go through and see, which each tool, for how long it's going to take for each tool. So that first tool, second tool, third tool, fourth tool. So we got just a few minutes on those finishing. The roughing is kind of what's taking the bulk of our time right here. So what I could do on this one too is like, well, God, like I said, I haven't set any feeds and speeds with this particular part right here, but I'm wasting 14 hours on this. I got to get that improved. Boss is going to fire me. So, you can come back in here and, maybe we don't need to do as many step downs, and I can get a little bit of more of a stout end mill in there, or taper end mill, and take more hefty cuts in there. So that is nice. Thanks for Ronnie for reminding me about that one.
No doubt. No, it's always, Kevin, a balance between, you know, speed of getting the material on the machine and off, and what types of finish you need or require or whatnot, right? And that's where playing with the software a little bit, you can really fine tune that.
Yeah, absolutely. And like I said, you know, the nicer the finish looks, the more cycle time you have, unfortunately. But it's you just got to find what you're looking for versus you know, in return of the cycle time. So.
Yep.
Oh, I got Ben. Oh, and material. What feeds and speeds? Oh, I didn't set up any feeds and speeds, Ben. This one would be a, you know, I guess we could say this impeller is aluminum here. Let me just look and see. You know, doing a cutting feed of 100 millimeters a minute, or like I said, I think these are just the default values that I just, when I added a new tool, that kind of come in. So you guys definitely pick your guys' feed rates that you guys are comfortable with. You know, especially for roughing, we can crank that baby up since we're leaving, you know, 0.35 millimeters on the wall and the floor. Don't really have to, you know, I can blaze through there pretty fast and not really have to care too much about a finish, as long as I just don't snap off my end mill. So,
yep.
But any other questions, guys?
Doesn't look like it, Kevin.
One.
Ronnie, can you expand on that a little bit?
Even through the passes, or even through the part.
Even though?
Oh, sorry. Even though the part.
Yeah.
One, even though the part. Metric and set it. Ronnie, you got me a little. Are you talking with my feeds right here? Oh,
there we go. Yep.
Yep.
Speeds and feeds in inches for sure.
Yeah.
Right, Kev?
Yeah, absolutely. So this one, when we set up the tool, was set up in millimeters. If we go add taper end mill, if we switch it over to inches here, we get should be. Wait, no, I started. Sorry, I take that back. I started this project in metric. So if I have tools that I can pull in that were already created within inches and feed rate set to inches, then we'll have inches populated right here. But since I'm just creating a new tool on the fly, then it's going to be defaulted to millimeters, and that's because let's see, no, I don't want to save that. In my properties, you'll see that my main, when I said SolidCAM new milling, that shows metric. So machine is still 18,000 RPM and max feed. Well, Ben, are you asking for your part? What's a good max feed? I'm asking what tech Okay, I'm getting a little confused here. I'm asking what tech Mac is capable of. Tear the. Or what machine are we running this on? Is that what you're asking? Oh, okay. Sorry. So this is actually on our Hermle 5-axis right here. So we have a max spindle RPM of, oh, they got this one kind of hidden in here. Let me see if I can find it. It's like 50,000 RPM spindle on this one, with a max feed of 1500 millimeters a minute is right here. So,
and that would be all specific to the particular post processor, Kevin.
Yep. So this is all based off of your post. So if you guys are running, you know, a Haas VFSS, you know, obviously this would be in inches, or maybe you guys are running metric, but you know, that would be, you know, 750 inches a minute, or I think the SS is like 1200 now, 1250. Can't remember right offhand. But this is already kind of set up for you guys from the post team of what the max that your machine can handle. Anything above and beyond that, we will get alarm saying feed too high or feed rate too high. I see that most commonly in iMachining more than anything. And what that kind of entails is getting off a little tangent here, but you know, this right here we're doing, so the post processor is telling us that we can do a max of 15,000 millimeters a minute here. Now, if we go over to our iMachining, and I know I have I know I got a Hermel in here somewhere. Where is it? Oh, maybe I don't. What's happening is, let's say we'll just grab this VF4. The feed rate right here is higher than what the VMID is saying. And we've kind of run into this, or I just kind of ran into it the other day with a customer. You know, it says 650 right here. You know, maybe our post and our VMID file says only 500, but the customer is saying, well, it's only cutting at 50 inches a minute. Why am I getting this alarm? If it's only cutting 50 inches a minute, you know, I've told it up here at 650. Well, you got to remember with iMachining, what it does, it doesn't, for the shorter moves, it doesn't switch over to a G01 or a G00. It stays in that G01 and does a high feed move. And it's going to be pulling that high feed move from right here. And then, you know, if this is saying 650 on a high feed move, but the VMID file is only limited to 500, that's where we're kind of getting that error. So
safety first, yeah.
So, and I was hoping to have this actually in a machine sim, but I couldn't pull it together in time. I do have a Hermle machine sim that I like literally just got within probably about 15-20 minutes of the class starting here. So I didn't have time to bring that in real quick, but if you guys are curious to see what that Hermle would look like in the machine sim, I can just do a quick little video after this one and show you. But Ben, what are you running for a CNC right now? Nada.
Working on it. It's coming.
Are you looking to buy a machine? Possibly not. Maybe. For, you know, from just previous experience, it all depends on, you know, kind of what you guys are doing here. But, you know, what I think I've noticed is we actually had a Micron machine in our Pennsylvania office, and that thing was extremely impressive and really rigid. The only problem is the price gets a little bit up there, so kind of you get what you pay for kind of deal. But if you're kind of in the things of looking, you know, all on accuracy and how much you want to hog off, that's a great machine. Or, you know, we have a couple Hercos that we've used all the time, are all great machines. But it's just kind of how deep is the pocketbook for you? Because it goes from, you know, buying a Geo Metro all the way up to a Lexus. So, yep, perfect. So, any other questions, guys? If you know some cheap for sale, I have some hobby projects. Yeah. No, and if you guys are looking to, this kind of came up, or we're kind of getting off subject again, but it has come up in the past of, you know, if you guys are trying to run a program and just don't have the time to kind of get it done, let me know or let your account managers know. We have one gentleman that does do some contract programming, or that's all he does is contract programming. I don't want to say a name quite yet. He is in this night class, but does extremely well job with contract programming too. And if you guys need that or are interested in that, let us know and we can point you in the right direction also. So we're here to help you no matter what it is, computer needs, tech needs, need to get that part machined. So let us know what we can do to make it a one-stop shop for you guys.
Agreed.
Stevie, am I missing anything?
Nah, I think you covered it all. I'll just toss it out there too. Please keep the ideas coming. What are we covering next week, Kevin?
We are, for popular demand, I've gotten this email quite a bit. Everybody wants to know more about the turning side of things. So we are going to start with the basics of turning next week. I think Jack, I know he emailed me today asking about it, and let me just see if he added it in there. SolidCAM here. Stevie, is there still a webinar tomorrow? I think that's it.
I believe we're doing a live cutting. Yep.
3
o'clock Eastern, if I'm not mistaken. So.
Okay, so he's just got the one in here. So we're going to cover in kind of going through, we're going to be taking a little bit of baby steps in here just because I don't want to rush through it. I want to be able to go through this with a fine-tooth comb, especially some of these, I'm not going to say simpler, but some of these easier operations for you guys. So we're going to be doing facing, turning, getting through the basics of the turning side of things, and then we're actually going to start getting into the mill turn. I've gotten a lot of emails from you guys asking to get over into the turning side of things, so we're getting over to there, and then once that's done, there's been a couple of random ones that have been emailed over to me also, so we'll get those added in there too. So
sweet.
But guys, that's all I got. Any questions, concerns, definitely let me know what we can do to help you out. You guys have my email address. If you guys don't have my email address, it's kevin.rankle, and that's R-A-N-K-L. I know it's a goofy last name. I didn't pick it, but at solidcam.com. For those of you guys that are watching it on YouTube, it will be in the description of the video content. So if I just go to our last video here, just come down here, click show more, and here is my email address right here. So definitely let us know what we can do to help you out. And if I can't get you answered, I've gotten quite a few international ones lately. Just like the translation is just a little bit off, so I kind of put you guys in touch with the right contact for, I think the last guy I talked with was speaking Italian from what I could gather of Google Translate, but did my best. But shoot those over to me and we'll get you pointed in the right direction. So.
Perfect.
All right, guys. Well, have a great, wonderful night, and we will talk to you guys next week. And looks like, Ben, we will be talking to you tomorrow.
Sounds good, everybody. Thanks for your time, and appreciate your attendance.
Yeah, absolutely. Yeah, definitely appreciate the time and sticking through these classes. I know they get a little lengthy and kind of get off on some talking tangents, but I think it's a great talking class. And like I said, let us know what we can do to help you guys out. All right, guys. Have a wonderful night.
Thanks, Kev. See ya.
See ya.